Next, we'll start discussing some fundamental data preprocessing techniques. It's important to understand the underlying logic behind these techniques, not just the programming skills required to implement them. Of course, programming is essential, and you'll need to implement these techniques in your assignments. However, if you don't understand the logic behind them, you might struggle to decide which techniques to use when dealing with complex real-world problems. Therefore, during exams, we'll primarily focus on assessing your understanding of the logic behind each technique. Assignments, on the other hand, will focus on the practical implementation of these techniques. Before diving into specific techniques, let's first attempt to fix the issues in this dataset. Starting with the missing values, the simplest and most straightforward solution is to delete the two data points with missing values. On this page, I've used gray to indicate the data points that need to be removed. Alternatively, we could try to fill in the missing values. For example, we could use values from similar data points to fill the gaps. This approach requires us to determine which data points are similar, and we will discuss several common techniques for doing this later. Another issue is consistency. In the previous example, we identified two inconsistencies. 1. The number of items ordered does not match the total count of items listed. 2. The order time has inconsistent formatting. These types of inconsistencies can disrupt the learning process and need to be addressed carefully to ensure the dataset is reliable and structured properly. Before diving into specific techniques, let's first attempt to fix the issues in this dataset. Starting with the missing values, the simplest and most straightforward solution is to delete the two data points with missing values. On this page, I've used gray to indicate the data points that need to be removed. Alternatively, we could try to fill in the missing values. For example, we could use values from similar data points to fill the gaps. This approach requires us to determine which data points are similar, and we will discuss several common techniques for doing this later. Another issue is the inconsistent time format. In this dataset, we can see that only one data point omits the leading 0. To fix this, we can simply add a 0, which is an easy and straightforward way to resolve the inconsistency. As for duplicate data, if we are certain that it is indeed a duplicate, the solution is quite straightforward. Simply remove the duplicate entry. Using duplicate data is problematic because the model will give undue weight to the repeated data point, effectively treating it as twice as important as the other points. This creates an imbalance in the training process and is not reasonable. Removing duplicates ensures fairness and consistency in the dataset. Finally, let's consider how to handle this outlier. This is not a general outlier, where we simply identify one value as being significantly smaller or larger than the others in a straightforward list. Instead, it's based on our intuition. As the number of guests increases, the number of items ordered should also generally increase. This relationship between features makes this outlier stand out, as it violates the expected pattern. Addressing such outliers often requires domain knowledge and careful analysis to decide whether to remove, modify, or keep them, depending on the context of the task. If we plot a graph based on these two features, we will notice that the red data point is significantly distant from the other data points. This makes it a clear outlier. Specifically, if we want to find a line that represents the trend of data distribution, ignoring the red outlier makes it much easier to identify the green curve. I hope this example helps you understand that, in many cases, outliers are not very obvious. Especially when dealing with datasets with numerous features, it becomes difficult to detect outliers through mere observation and reasoning. In general, data visualization is the most effective way to identify outliers. Outliers typically stand out in visualizations as they fall outside the region occupied by the normal data points. To make it easier to identify the overall pattern, represented by the green curve in the figure, the best solution would be to remove the red outlier. While it's technically possible for 6 guests to order just one Coke, in reality, it's an extremely rare occurrence. Such exceptional cases are not necessary to consider in most tasks, as they are unlikely to contribute to meaningful pattern recognition or generalization. Removing this outlier helps the machine focus on capturing the more general trends in the data. Finally, let's take a look at the result of data preprocessing for this example dataset. As shown, the gray rows represent data points that were directly deleted as a solution, while the blue rows are the available data points that were retained. We can see that only 3 data points remain available. This is not a good practice because, out of the original 7 data points, 4 were deleted. This leaves too few data points, which may not capture enough information for the machine to make rational predictions. Remember, in most cases, we should avoid simply deleting data points unless absolutely necessary. Data is valuable, and we should try to fix issues whenever possible to retain as much useful data as we can.